me right now? Can everyone hear me? I think they can. They're saying in chat they can. I hope they are. Can everyone online hear me? Yes or no? Can they hear me? Yes, they can hear me. Oh, no, scare me there. You scare me. Should we start with the good news or the bad news? What does online want? Good news or bad news first? You guys want bad news? There is no bad news. Let's go to the good news. What kind of bad news? You can define news however you want. I could be like, we're going bowling, and everyone will be like, yay! Then somebody will be like, we're going bowling? It's all perspective, right? There's no such thing as good news or bad news. Project 1 is released. No, that was Pivot. So everyone's all sad now. How do you guys feel? Project 1's released. Let's see. How's everyone? Has it? Yippee! Luke is happy. Luke is hurrah! Look at it's so happy online. Who has looked at Project 1 so far? Has anyone looked at it? And how do you guys feel about it? Does it look really long? If you notice, it's got a lot of instructions. It's got examples. It's, I think, 9 pages, but how many pages is the project really? How many pages is the project really? Like the actual part of the project? Like 1 or 2? Just 2 pages. There's only 2 pages. Everything else is instructions for it. So when you open it up, it's just got lots of instruction. It's basically like we wanted to make this as impossible to mess up as we could make it. So don't feel like you have to read every little thing, because if you come to StatLab, if you come to my office hours, I'll be talking you through it. I'll help you understand what's going on, and I'll walk you through, like, here's what you need to do for this question, here's what you need to do, so you don't have to read every little word. So do not worry. It's meant to be very, very, very thorough in how we tell you what to do. So we will see that. Let me show that right here. I might as well show Project 1. To get to Project 1. So we are viewing the online. B. Stevens, Stat 1. We're supposed to get the Stat 1 domain soon, I hope. That was something I was working on this semester. Here, I'll show that here next. I'll put that up right here. So here's where the project is at. Fixed. Cool. Just make sure everyone knows when you come in. Don't worry about your audio, because I'll be the only one with audio. So here we go right here. Make sure I'm the pin video. There we go. Cool. Okay. So everyone can see the screen right now, I believe. And here's where the project is at. Does this make sense where the project is at? Also, if you're wondering where the applets are at, well, here's the project. You need to download Jump. We also have a Project 1 playlist. I'll be adding a Tabulate video on here soon. So if you get knee-deep into the project and you're like, I'm totally stuck because I have no idea how to use Tabulate, don't worry, it's not that crazy. It's a little weird, but it's kind of neat because you can make tables of summary statistics and stuff. Very easy to use once you know how to use it. I'll have a video coming shortly for it. But you can see a bunch of videos which cover a lot of what you'll be doing in Project 1. And there's videos right here on how to install Jump, how to make histograms, how to make box plots, how to make mosaic plots. This one has stem and leaf on it also. You don't need that one, but there's a video for each thing you would need in Jump. So don't worry about getting stuck on how to do anything in Jump. You can email me, you can watch the videos, you can come to StatLab. We're here to help you on that. But it won't open again. Oh no, Luke, are you on a Mac or a PC, Luke? If you want to get to it on a Mac, do this, hit Command Spacebar and type JMP, and you should see Jump 14. If you guys didn't notice on your Mac, Command Spacebar is global search. Does anyone use that? Surely no one uses. Do it on your Mac right now. Hit Command Spacebar, and you're actually searching your whole Mac. It's really cool. One of my favorite things to do is just Command Spacebar, and you global search your whole Mac. So if you're looking for a file, you can just start searching, or a program. Did you guys try it? It's pretty neat, right? You search your whole Mac. It's really good, really helpful. If you do have Jump installed, it should come up with Jump 14. If you're on a Windows, you can always hit Window button and type JMP, and that's the global search on the window. So the analogous window option is to hit the Window button and then just start typing. Don't worry about where you got to click. So that's how you global search on a PC, Window button, and global search on a Mac, Command Spacebar. Really great. Command Spacebar is awesome. If it's not showing up, you might not have installed it. We'll look into that, Luke, and figure out what's going on. So here's where the project is and the Project 1 playlist. Those apps that I was using can be found under distribution. The normal curve applet is right here. So if you were looking for that David M. Lane applet, good job. I hope it works, Luke. Here's the normal curve applet. Does everyone see that? The Stats 1 homepage has a lot of what you'll need, including any of the distributions. We have the 2 sample T degrees of freedom, and they bring you right to these pages right here. We've got jump tutorials. These are the ones Charlie wrote, so there are more jump tutorials. They should be up-to-date-ish because jump keeps updating. So I have pretty up-to-date stuff on the YouTube channel, and here's our online resources and all this good stuff. Yay, cool, Megan. Glad to see that. So if you answer something, put like Brianna beside it. So I like that. So, or Megan's watching with Brianna. So does everyone understand where the project is at? The project is due when? I like that. Everyone's saying Wednesday. It's due next Friday for regular credit, but when should you get it done? I definitely think you should get it done Wednesday. So what you'll see is a lot of times we'll have a project before a test. The project's usually a good review of material. You're gonna be going over the mean, the standard deviation, the IQR, the Q1, the Q3, box plots, mosaic plots, all these things we've been learning and doing some interpretation. Sometimes we pick a question like, how do you know that there's an association in this mosaic plot? And let's show one right here. Why not? You guys want to see me make a mosaic plot, which is part of your project? Has anyone been doing the project and they're stuck on something? I'll show a few things here. I'll show how to use the Tabulate. So if you say, Brian, you didn't make a video yet, you're letting us down, come on, I'm almost done with the project, I got stuff to do, I want my whole week free. Okay, calm down. I got you. Let's do this, you ready? Let's make a mosaic plot here. Let's pick two variables at random. What I'm gonna do is I'm gonna click this red arrow, and I'm going to only look at character, because mosaic plots only use what type of variable? For 50 points, raise your hand, or online, mosaic plots only use, right there, categorical. Exactly, first person online says it gets it too. Categorical variables go into mosaic. So I went to character. Looks like a good drink there. So, no, just looks like a Frappuccino or something. No, it's what? Milkshake. Oh, milkshake. Oh, steak and shake milkshake. Oh, you didn't bring enough to the class? Unfortunately. We'll just pass it around. That's a horrible idea. All right, so let's see here. Climate change based on people's, let's see here. We got views on political issues. Let's go here to social views and climate change. And I do like this one and I don't like it. I'm going to show something here what I do and don't like about this. I don't know how to spell it either, Luke. 50 points to Luke and Gabby online too. If you notice here, let's just look at this graphic for the moment. Do you see how people's views on climate change generally change based on, guess what, basically their political, is that a shocker to you? So if we go to it's happening and it's humans are causing it, very liberals like overwhelmingly agree. But we do have people who are very conservative who agree with that stance too, but you see more of a spread out here on the views. So do you see what we're seeing with the mosaic plot? Well, we can look at the x variable and how it differs based on the categories of x's. Now, I love this one, but it's not showing up so well. What we're going to do is we're going to go back and relaunch this analysis, and now we're going to go social political view, and let's see what categorical variable do you guys want to talk about here for this? Social political view and what? People, what is it? People what? Vape, okay. I thought you said bake, and I was like, well, we kind of have that on here too. So is it vape safe? We could do marijuana. Sure, let's do that. See who's smoking weed. So here we go. Who's smoking weed? Do what? We all knew this one. We all knew this. And guys are like, that was obvious, Brian. Come on now. But do you see how we can explore these variables? And the way I want you to read this is, does X explain Y? Does someone's social political view explain whether or not they've smoked marijuana? And so this one will work pretty well. Remember, this is recorded, so if I do a bunch of quick clicks, you can go back and pause the video and slow down everything I've done. So I'm going to go here and I'm going to remove these, total and count, or column percentages. And now I'm going to do a trick. This is a trick you don't have to do, but it makes things look nice. Right here, this is the third option on the Mac, and you have to find the secret PC menu. I'm going to click this, and then I'm going to click this. You see my hands are free. Do not click and drag, or if you click and drag, it'll do this, or it actually worked that time, and I messed it up. So if you originally just click, I think it messes up, click and drag, it does that, but you need to click once, and then drag. And once I go to right here, it appears beside it. And that's a good screenshot. This is nice and neat, so we can go to Snipping tool or Command-Shift-4 on a Mac. There's a video on this too. And we go to Snipping tool, and we take our nice, clean screenshot, and this is 2A, I believe, on the project. So I've literally just done a version of 2A. I'm not using my random sample. That's question 1. Make sure to use your random sample. But if this was a random sample and you had done it, you'd be good on the project. This is what we're looking at here, and let's see how we'd explain this. This could be on the test. Use the row percentages to explain the relationship you see between people's social political view and smoking weed. People who are very liberal, what about them? Correct. And what percent of the very liberals are doing it? Do you see this number? I can that right there. Now I wouldn't put this in your report then, it looks a little bit weird, but 76.6 compared to the very conservative 50%. So we basically go from 3/4 of people doing it to only 1/2, which still it's the majority of students in any group except, conservative. But maybe that's just randomness, right? Because it's pretty close to the other one. So this is what we're looking at here for you to mention these percentages. As you did in your pivot, mentioning the numbers is key here. You'll see it says in the report, mention the row percentages. And so the last thing I'll show right here, this is how to make a mosaic, which that's basically 2A is just 2 mosaic plots and doing the proper graphics. So now we're gonna go here, and this is not quite your question, but I'm gonna go to the Tabulate feature. So under Tabulate, I am going to choose the min, the max, and the median. I'm gonna drop them into here. Then I'm gonna grab the quantiles, drop it into here, and I'm gonna type in 25, because what do you think I want? You know what I could do? The 25th quantile is the what? I'm gonna start over because I'm gonna do something. I'm gonna grab min, and then I'm gonna go up to here, and I'm gonna grab quantile. They might be saying it online, I'll give a good 50 points. Why am I putting in, I'm gonna put it right there. And are they saying there, Q1 online, 50 points there, and also attempting class, 50 points? I like it, that is Q1, right? Then what do you think I'm gonna put after Q1? The what? Median there, 50 points. Median, what do you think I'm gonna put after that? Q3, everyone's saying these 20 points. Keep these answers coming because we're putting Q3 right here, which is the 3rd quantile. Last but not least, the max. We have just written out the 5-number summary. Remember, if you ever are confused on the 5-number summary, do your 4/4, and then remember it's the percentages because the min is the lowest. Then after you count 1/4, you're at what? Q1, and then after 2/4, you're at the median. After 3/4, and then at the very top, you have the max. Just draw your 4/4. I always ask people, draw your 4/4 and put your lines. It's pretty easy. Now we're just gonna take the variable we want. This is not the variable you want, and drop it into here, and boom, we have it. Now, if it was displaying the decimals weird, which I guess I could make it do that, let's go to pet expense and see if we can get some crazy decimals. We still don't have them because I want to show you everything we could possibly show in this. It's not doing it. That's kind of cool. Age right here. We can make font bigger, or I thought I did it. Let me do Control-Shift+. There we go. So I'm making the font bigger with Control-Shift+. You can change the style of this table down here and change format. And for your question, you will have to put in like 6 for this, or else you get crazy amounts of decimals. I don't think we'll count out points, but that changes the way it does the decimals. And we have a nice, neat table here. Does that make sense? So you can use this to create tables of your summary statistics, and you kind of saw me do that process here where I'm just dragging them up into the rows, and then, or the columns, either which way, and then I just put it in the other spots. It's almost like your pivot tables, right? So this is just creating summary statistics for us, and you'll use this a lot in question 3. Go ahead, question. Sure.
But are we supposed to screenshot?
Yeah, so if you're on a PC, you'll just go here to your snipping tool and just grab this right here.
Okay,
And
so just
just this. You can also hit done and then screenshot it here, either or, but if you notice, this is the same. So we just want you to add in the screenshot of it, and nice and neat. So for those who have worked on the projects, does it feel like I did a lot of the project right here? Yes, I like that. We are 15 minutes in and we just worked through almost everything on the project. There are videos for everything else, and please comment up if you have questions, but all you're doing is just kind of interpreting data and just making graphics with data and summary statistics. So please ask questions. When is TAlib again? The TAlib schedule is posted. We'll be on overstaff next week. Let's show where the TAlib schedule is, and please tell us if someone's not in there. Oh, it's going to be fun because all of our TAs basically have the same thing. TAlib, you can see the weekly schedule here. I actually had to cancel Wednesday morning. I had a meeting I had to get to, so that came up as a late cancellation. This should be the most up-to-date thing, and we keep, I'm sorry it's closed during this part during the day. We just don't have any TAs who can work it. But this is as much as we could staff it. If you're looking for the location, it's in Hodges Library. And you can see it's just, you go into the North Commons, which this is the Commons at the back corner. And then just go into the back and you'll see it all the way back here. Ignore the sign that says Math Lab or Math Tutorial Center. It's TAlib during the day. So that's where it's at. And we've got everything, location, weekly schedule, all this good stuff here. If you can't find it, here's where to find where the location is. Great question, Gabby. I'm throwing 20 points right there. And I think we're going to the TAlib schedule. Do it, I think. Did that help, Chelsea? So this is locations right here, all this good stuff. And a little information on it can be found right here. We do close during different times. And next week, we will be on overstaff. And we'll be on overstaff the following week for test 1. Look at all this good news. Wait, we didn't even give the real good news, did we? All right, so we just went through all the project stuff, right? You guys remember the survey? Do you think we got 1 point? Yeah. Well, we did at least get 1 point. Yeah. Did we get 2 points? Did we get 3 points? Yes. Did we get 4? How many points do you think we got? 3. We had over 90% respond. And we actually just barely had 90. We literally had one person enough to have 90. So if you took that survey late at night on Monday night, thank you. Find that friend who did it late at night on Monday night for our class and be like, thank you so much. You got me 1 point on the test. Well, we were all actually part of it. So we got 3 points on our first test. There were a few classes that got 4, but hey, are you guys happy with 3? Would you have, it's fine. We got 3. Some classes got 2. I think another class might have gotten 1, but we're in the top tier of classes. So thank you guys. Thank you. Yay! I was willing to do the slow, awkward clap, but thank you guys very much. Thank you very much. I don't feel as awkward now. Only that much less. So we got the good news. Clap points, John, 20 points. Everyone who clapped 20 points, you clapped at home 20 points. So you guys ready to have some more fun and do some more statistics today? Let's do it. So we got everything out of the way. We know what's going on with the project. Pivot assignments due when? Tomorrow night. Get it. It's 2% of your grade. How long did it take you guys to do? 15 minutes. Maybe 30 minutes, maybe an hour, but it's not that bad once you know how to do it, right? There's videos. Has anyone emailed me their stuff for me to look over? Some people have. They might be saying it online, but people have emailed me their work to look over. I won't grade the whole thing, but I usually look at your pivot charts. And I'm like, you're missing this or you need this. I'll usually give you advice. And if you're stuck, I'll point you in the right direction. So don't worry, we got this. Let's see, got this. So let's hop in here. We're going to do a little bit of review today on the normal curve because I know this is a tougher chapter. I keep saying to people, if you know the normal curve, you got it. And I want you guys to ask questions today, and I'm always open for you guys looking at a question of sorts you're stuck on, so also feel free to throw those in. Okay, let's make sure we know everything we need to know here. So when it comes to the normal curve, the most important numbers we need to know, we're going to do this. First person to raise their hand or say it online gets 100 points, and you need to know those numbers perfect. What are they?
99.
Cool. I didn't correct you. I squinted. So you got it right there. And online, I see John right there. I'm going to throw another 50 to everyone. Everyone raise their hand in class. Everyone who said online, thank you. You need to know these numbers. 68, 95, 99.7. One time I had a student yell that to me on the strip. They were like, 68, 95, 99.7. I was like, what does that mean? They yelled like, I don't know. And I was like, what am I teaching you? What am I teaching you? What does it mean? Another 50 points online or in class. What does it mean? You should have said 1,000 points. Go ahead. The percentage of area within the standard deviations on the normal curve. Does that make sense? So you should be able to say, hey, Brian, those are the percentage of data within the standard deviations on the curve. As in, 68 means within -1, +1 is 68% of the data. Within -2, +2 is 95% of the data. Within -3, +3 is 99.7% of the data. And this is a rule of it's the empirical rule. These are roundings of the numbers. If we want to get the exact numbers, we go to an applet. And at least I know, did anyone take Math 115 or AP Stats or anything like that? Do you guys ever use like where you have to use a z-table? If you ever see a z-table, burn it. Get rid of it. Those things don't deserve to live. Sure, you get it, Colin. You definitely get it. So burn those tables. They don't deserve to exist. Because the table is just a bunch of numbers someone wrote down. What's better than a table? Being able to calculate anything on the fly. You can enter in here as many decimals as it will accept, and it will tell you the answer. I can go over to RStudio and do the same thing and get it to report even more decimals. We don't really need anymore, and I say this very confidently, we don't need a table where someone just writes down all the numbers that this thing can calculate. We can use it to calculate ourselves. And I always say, every time, I've got this on my phone. So someone's like, you won't always have your computer. I'll be like, I'll always have my phone. And what do you know? You always have two. You always have the empirical rule in your mind. So last question before we start lecturing a little bit more. If someone said, Brian, what is the area above 2 standard deviations? What would I say? Basically, what percent? Raise your hand. Online or in class? 50-pointer. Go ahead. Above 2. Above 2. Say it again. 2.5 right there. 2.5. And it's more like 2.24, 2.23. Rounded. It's very close. Or 2.28. It's because it's not 95, it's 95.449. You don't need to know these exact things. What do we keep memorized in our head? 68, 95, 99.7. And then whenever we want an exact number, what do? Use an applet. That's the key right here. You don't need to know all the exactness because you'd use an applet for that. You'd have it calculated for you. So you can use the empirical rule as a quick guide in your head, or if you want an exact answer, you'd use an applet. So that's what we teach right here with this. So z-tables, no. They're good for tests, but other than that, Brian really hates z-tables. No z-tables. So you will have things on the test, and let's see if we can kind of make up some questions as we go through this. So what you'll notice here is that a z-score of 3 is very, very large because things that would occur, so remember this, a z-score beyond 3 or -3 is an outlier. Key note right there for you to take with your taking of notes. A z-score outside of +3 or -3 is an extreme outlier. You see that here in the slides. So with that in mind, what percent of data would be extreme outliers? That would be a decent test question. Go ahead. Exactly right there for another 50. We're throwing 50-pointers today. Keep up all those answers online too. But outside of -3 and +3 is only 0.3% of the data because what's inside of there? 99.7, right? So that's why 99.7 inside, 0.3 outside, very, very unlikely for something to be an outlier. It's very few outliers when you look at normal data. But last time we ended class with a very important thing. So make sure to have this note. We should only use the mean and standard deviation when the data is, you can tell me one word, the data is normal right there, normal. Mean and standard deviation for when the data is normal, meaning it's 2 words. 20 points each word here. I want to see those words online. You get 20 points for each word. It's 2 words. It is kind of. Say it again. Unimodal and symmetric. Livia, nice job on there. Livia, nice job there. Unimodal and symmetric. Try to draw something that has one mode and is symmetric. You have to draw the normal curve because you have to put a peak to it, and then it has to be symmetric around that peak. This is like one of the first things I learned in stats. I was like, I can draw something that's unimodal and symmetric and not the normal curve. You can't. You can make weirder looking ones that are like pushed down, but it will still have one mode and be symmetric around that curve, around that mode. So you basically have the normal curve, and we do have a thing for peakedness, but we won't get into those types of stats right now. So with this in mind right here, we can see how things are calculated. I want to make this very clear that you should never, ever, ever do something like this. You can't say that 81.5% of the data is within 0.15 and -0.15. Because the curve, if you notice here, there's more data on this side of 0.15 to 1 than there is on this side of 0.5 or -0.15 to 2. You can't just start cutting those up. You can only symmetrically cut the curve. So any symmetric cut is fine, but don't start slicing these segments in half. I'm going to give you an advanced question here in a moment that we usually write on test 1. I still have not seen test 1, so there's always a chance it could be on there. We're just showing how to use the applets right here, replicating the 68, 95, 99.7 rule. not too much going on. We're basically doing cleanup. Please slow me down. I feel like I'm going fast, but does this sound like review right now? It does. That's why I'm kind of going fast, but please ask a question if you haven't. The last thing that I said we covered again was we should use data. We should use the mean and standard deviation when the data is normal. The first way to tell if the data is normal is to do what? The very first way, to simply look at it. Look at the histogram. Make the histogram, look at the histogram. Look at the histogram. Way number one, so take the note. Checking to see if something is normal. Way number one, look at the histogram. That's not really a good stat way. Like, that's not advanced statistics. Like, we don't just look at stuff and say, we're done. Way number two is on the screen right now. Way number two is to do what? Nice job, Luke. 50 points, Luke. You've answered a lot today. I love it. Go ahead. Normal probability plot. And the way we look at the normal probability plot is if we look to see if it's what? Straight or bent. Exactly there for 50 points. Straight or bent. This one looks less normal. This one looks more normal. Notice the histogram on the left that looks normal, and now it doesn't, and it's bent. The straighter this line, the more normal it is. Question in the back. Go ahead. Second way to tell if the data is normal is to look at the normal probability plot. If the normal probability plot is straight, it's pretty normal. The more bent it is, the less normal it is. So the graphic on the right, straight, and now it's bent, less normal. From the histogram, the graph doesn't look that symmetric. How can you tell from that? Great question without the normal probability plot. Olivia, amazing question. And the answer is, a lot of times, maybe in advanced statistics, I'm about to do a major thing right here. Do what? So nothing in the world is really normal. Sorry, none of us are. With that in mind, if you get a large enough sample, you'll eventually find that nothing is normal. So a lot of the times, especially in 320, if you take that class with me, we'll actually look to see if something is normal by just looking at these two graphics, and we'll really focus on the normal probability plot to see if it's straight. Because the problem is, and this bridges to a later topic, is when you do the third method to test if something's normal. When you get a really big sample size, your test is really powerful. You'll hear that word later in the semester. And that means you can basically figure out if you should reject the null. Don't worry about that too much. But if your test is really powerful and you can figure out that something's not normal, and I told you nothing's really normal, your p-value with large sample sizes when you test for normality will often come out very what? Careful. Low. Reverse. Yes. Because when the p-value is low, reject the null. So you'll basically reject that everything is normal with large sample sizes because nothing's normal. And if you collect enough data, you figure out that it's not normal. Don't worry, it's a big kind of a, we're not really getting into that right now. It's just a theoretical thing. Because nothing's normal, and with a large enough sample size, you can find that what you're looking at is not normal. So luckily for us, this is not a ridiculously large sample size. So what is considered low again? 0.05. So always repeat in your head, when the p-value is low, reject the null. Is this p-value low? I do not reject the null. And p-values are probabilities. So we say when the p-value is high, just let it fly. Just let it be. Don't do anything to it. So just read me the null right here. The null says the data is from the normal distribution. Are you going to reject that or not reject it? Wait, is the p-value low? Just let it fly. Just let it be. So what are you going to continue to believe here? That the data is from the normal. And data is normal. That's a great way of saying it too. The data is normal or is from the normal. And then we see down here, this p-value is low. And do you see how it's a little more skewed? This data looks less normal. This has a little more of a bend to it. Kind of, those are not the best ways because you're kind of like making a judgment call. But here with the p-value, is this p-value low? Is it below 0.05? So, and what is the null again? And this is key. We should always think, what is our null? Our null is the data is normal. So you'd say, Brian, I reject that the data is normal. I have evidence it's not normal. Question, go ahead. And sometimes you see H0 or H1. Sometimes we'll write that way. HO, it stands for H naught, and HA we write for alternative. So we have the null hypothesis, and HA is the alternative hypothesis, null HO with a subscript, and HA is alternative. In other courses, you might see H0 and H1. Have you guys seen that before, H0, H1? Some courses do it that way. It just means you're null in your alternative. I think they usually write 0 or O, like null and 0, because it's where you start. The null is your beginning belief for anything. So we're believing this is normal to start until our data looks like it couldn't possibly be normal. And with this right here, with what we observed, if it's normal, our results, this would occur 28% of the time, or something more extreme. Does that sound possible that it's normal? If I told you there's a 28% chance it's going to rain today, do you think it's going to rain? Like, could it rain? Yeah, I mean, what if you had a big interview? Would you bring an umbrella? You wouldn't? Big interview, and you're wearing like nice like silk or linen or something you don't want to get rained on. 28% chance of rain. Is that, I'll be fine. Would you grab an umbrella? In the car. So you have an umbrella in the car, so you have a backup. But think about this one. In this one, what's the chance of rain? Go to the probability. 3%. So these results seem likely or unlikely. Unlikely given the null is true. Our results here are unlikely given the null is true. So what are you going to do to your null? Because our results are unlikely given the null is true. You're going to reject it. You're saying what I saw is unlikely given the null is true. I bet the null is not true. But over here, you're saying my results are kind of likely given the null is true. I mean, they're not super likely, but they were possible, right? When you think a 30% chance almost, it's like, well, this could occur given the null is true, or results more extreme. So you'd say, I don't have enough evidence to reject my null. But down here, these results were less likely given the null is true. So you're going to do what? Reject it. So when we look at these p-values, which we'll see again later in class, even in today's lecture, which we're about to get to, the p-values are the probability of our results or results more extreme given the null is true. So if what we saw was unlikely given the null is true, we're going to do what to our null? Reject it. And we'll never accept the null. We'll just say we don't have enough evidence to reject it. Does that make sense? Like, because wouldn't it be weird to say, I accept that this data is normal? And you'd say, well, wait a minute, what you saw was only 30% likely given it's normal. It sounds kind of like it was kind of unlikely, right? That's why we say things like, I fail to reject or do not reject, because we did not have enough evidence to reject. Did we have some evidence? Does it seem like maybe it might not be normal? Like maybe? Would you want to bet your career on that? No, so you're like, well, it looks like it's a little not normal, but I don't have enough evidence. And that's when 0.05 is enough evidence. Does that make sense with the way we kind of talk in statistics? So we want to see if there is enough evidence. What if the p-value was 0.001? How do you think it would look? How would the distribution look? And I'll show you that. Would it look normal or not normal? How would it look if the p-value was 0.001? It would look how? And how skewed? Very. Let's check it out. Let's put this in here, a very skewed distribution. So remember what the null is? The null is that the data is normal, right? Does that look straight or bent? Bent. Does this look normal or not normal? So should the p-value be high or low? Low. If you said low, you're exactly right, because the null is that the data is normal. And when the p-value is low, reject the null. Does that make sense? If you followed along with this right here, I was able to think up an example where I was like, let me take some data that's crazy right skew. And then the normal probability plot should look very bent, right? Because that coincides with a skewed histogram. And then the goodness of fit test should come back with a what p-value? Very, very, very low p-value. Because the null is that it's normal. We're going to reject normality. Do you have a ton of evidence that this is not normal? Yes. Is it possible by like winning the lottery that this is normal and we just got a weird sample? Yes. But how do you feel in your confidence? We'll look at the zeros on this. It probably has a ridiculous amount. Oh, it just says 0. It couldn't even give us a p-value because it's like, yeah, it's not normal. Technically, you really don't get p-values of 0. It's just that JUMP didn't even want to estimate that any smaller that is. If I did something like GPA, GPA is probably not normal due to the left skew of it, or you see it's left skew and outliers right there. And this looks, you see how it looks a little more normal, but probably due to our sample size, it's going to come back not normal. I know that that looks normal. And so if it looks normal, we should get kind of a straight normal probability plot, right? There it is. Straight. Do you see that weirdness at the end, though? That's due to these outliers down here. But there was a good bit of normality to it, right? Do you see how it follows that line that it gives us? So I still think due to the outliers and the skew, when I run this, it's going to come back not normal. We'll see what happens. We want to go to continuous fit normal. I'm just going to put a normal on top of it. You see how it's got problems or it's escaping. And then we run the goodness of fit. It says it's not normal. And I know that it looks normal. This is a problem with a large sample size. I can show you, I'm gonna show one last example and I'm gonna make it come back normal. And this goes to your project. To take a subset, you go to table subset, and we're gonna decrease the power of this test and go down to just 50 students. So now I'm only doing 50 students right here, and let's do analyze distribution and do high school GPA, drop it in. I didn't get some crazy outliers. So now when I go stack, should it be straight or bent? Hint, it looks kind of normal, straight or bent, straight. So does that look kind of straight? Does it follow that line in the middle? Pretty good. So if it follows the line, looks kind of straight, histogram looks kind of good, the p-value should be what? High. Because the null is that it's normal, and we're going to let that fly. And last but not least, p-value is high enough. And remember, 0.05, above 0.05, high. And I was hoping to be a little bit higher, but hey, that's fine enough by me. We got an example of a normal now, and we saw multiple examples of non-normal. So definitely use these examples here to remember the 3 ways we check for normality. Look at the histogram, not the best way. Look at the normal probability plot to see if it's bent or straight. That's actually pretty good, and we use that a lot in 320. The final test can be the p-value, which when it's above 0.05, normal. When it's below 0.05, not normal. That's the way it works. Any last questions on this bit of review? I think we got it. I'm going to end class with a 200-point question, so stay tuned for the end. We're going to come back and do a review question, but for now, we're going to do a brand new lecture. No? Should we stop? We had a teacher a long time ago, I think I can say this now, who on the first test, he'd only gotten to like chapter 3, and by the end of the semester, he'd gotten to like chapter 9. And like, I know I love to tell stories, I like to do wacky things, I show a lot of examples, but he was very slow. He hasn't taught in a while now. He retired, but he got through very, very few chapters. And so he had to make his own test. And his first test was literally like box plots and histograms. Do you want him to come back and teach you guys? You guys don't like me? Yeah. He was a nice guy, but he didn't get through much material. So, all right. Oh, thank you, Luke. So let's continue on here. With this in mind right here, we've got correlation, associations, and scatter plots. So you guys are about to hear some of my pet peeves for the day. So what in the world is a scatter plot? A scatter plot is going to go from univariate to bivariate. So what is a univariate quantitative display of data? 20 points, raise your hand for each one, or say them online. You only get to the first one to say it. So say them in class. Go ahead right here. But what is a univariate quantitative display of data? Univariate quantitative display of data. Review questions right here. Go ahead right here. Histogram, boom, and they're saying it online. What else? Univariate quantitative. Go ahead. You got another one. You keep going. Who else wants to do it? We're losing them. We're getting. Yep. We got one more I can think of. You can always cheat and say the thing we're turning it on Friday. There you go. What else? We got one more that we should always remember because it's basically a histogram where we can see the numbers. Stem and leaf is a histogram where we can see those numbers. Remember what these things are? They definitely, some of them will be on the test at least. But now we're jumping into a scatter plot. Now, if you remember when we did univariate data for histograms, we had shape, center, spread. So when you look through the notes, be like, oh, if I want to interpret my histogram, it'd be shape, center, spread. Shape is like skew or unimodal or uniform, where center is either mean or median, and then spread is median and IQR. Range is kind of just in there as its own thing. Never hurts to give the range. But now we switch to strength, direction, form, and then usual features. I know it says it in a different order here, but that's the way I memorize it in my head. I don't know why it just sounds better to say strength, direction, form, unusual features. Because that S is strength, direction, form, and unusual features. So what are these 4 things? These are the 4 ways we describe. Raise your hand and tell me for 50 points right here. The 4 ways we describe. Yes, I'll take it, because a scatter plot is a bivariate quantitative display of data. Okay. The 4 ways we describe bivariate quantitative data. Bivariate quantitative data. And that's what we see right here. So let's start with direction. I know we've already mentioned a lot today, but I think you guys got this. Why not? Let's make this a 500-point question. First person online or in class.
There's a question.
I heard you right there. They're saying it online class. Luke got it. Luke got it. Fast off the gun, Luke. Negative. Would you guys like it? Would you guys like it if there was a question on the test that just asked you what's the direction of the scatter plot? So that's a good question. But it's one of the ways we describe it. So maybe on the test it might ask you to use, like, describe the scatter plot. So you're like, oh, I can tell the direction of the scatter plot. We'll see other ones in here that are positive. Like if we look at these, we'll ignore that it says strength on here. But the first one right here is positive. And then I would say that this is really neither, or you could say mixed direction. But these are really neither, but there's a positive. The direction is pretty easy to see. Does that make sense? And we have other directions right here. This one is positive. I would also say that this one is generally neither. So the three directions are positive, negative, or neither. Does that make sense? Your three directions are positive, negative, or neither. So just take a note, three directions, positive, negative, or neither. Nice job, Luke. Next, we go to the form of it. There's only two forms. The two forms are either linear or nonlinear. Which would be, exponential would be in the subset of nonlinear. Nice job online. If you generally say an answer to me and I respond to it, give yourself 20 points if I haven't, because sometimes I forget to give you points. But if you look at me and you say an answer, like, I said an answer, a little bit of the honor system. So we have linear and nonlinear. Two forms. Does everyone get this? Strength, direction, form, unusual features. Now we need to talk about strength. Okay, strength is one of my favorites, and it's going to come back up in chapter 7 and 8. The strength of a relationship is how tight that relationship is around its form. So that's probably the best definition I could give you. The strength of a relationship is how tight the relationship is around its form. So could you draw a relationship that is strong but nonlinear? What might you draw? Something like that, right? Do you see the middle one or the third one? So I always love this. Let's do this. Let's graph how people feel. Is one of my favorite things to do right here. Let's do a really strong relationship that everyone knows. We're gonna do. Who here? Did you guys hear? We have an In-N-Out opening. It's gonna open the. Well, I already got Cookout. I have to update my examples. We have Cookout now. So you guys still want In-N-Out? Yeah. All right. So we're gonna go to In-N-Out. You ready? Yeah. Okay. You hungry? Okay. Good. So what we're gonna do here is we're gonna make a scatter plot. Sounds good. So we're going to put in here burgers, and In-N-Out burgers are pretty small, right? There. Are they not? We're just going to get singles. We're not going to get doubles. Online's wanting it right here. So like how close, exactly, Luke, and you're going to see that in this example here. So we're going to have how you feel. So just feel, put feel here. So this is how many burgers you've eaten with how you feel. So you're really hungry right now, like you haven't eaten all day, probably not feeling that good. 0 means you're not feeling good, and it can be for any reason. It just doesn't mean that you're hungry. 10 means you're over the world, you're great, nothing wrong. So you've eaten no food today. It's about 5:40, 5:50. How do you feel? Give me a number. 1. Now you eat that first burger. Maybe these are kind of smaller burgers. They're not like Crystal Burgers or White Castle. They're smaller. How do you feel now? 5. Oh, 5 already? Woo! So, Julia, okay, you eat the second burger, how do you feel? 10. Oh, 10, okay, cool. So now you eat the third burger, how do you feel? You can't feel 15 though. You can only feel 10, 10's top. Still 10, you're feeling good, you're just relaxing. Okay, you eat a fourth burger, I'm paying. 8, okay, he's like, what am I doing? 5th burger. 6. Maybe you start to get like, you rally and you go back down. So we can do this right here. And so we're going to go right here and we're going to see here this pattern. Does this make sense? I call this the Thanksgiving effect. We've seen this. You guys know the Thanksgiving effect, right? We can see the burgers explaining how you feel. Can burgers explain how you feel? We kind of see this jump in the graphic. I'll make it look like this right here. Do you ever see where you start to feel really great? I think I can fit a line through this. Can I fit a line? Let's fit a special. This is kind of cool. We can fit a special spline. Look at that. A little bendy line, because you can turn it back into a line, or you can make it a bendy line. I know, it's kind of cool, right? So you can kind of see how you get this like jump. You're like, oh, maybe this was a good idea to eat 6 burgers. And then you eat the 7, you're like, no, it's a bad idea. It's a bad idea. But if everyone in class started to do this, we might see a pattern like this. Because we all kind of, do you guys know that Thanksgiving effect? Like you sit down, you eat that first place of food, you start to feel good, you eat second plate, you're like, oh, this is so great. And you start to eat the third plate, you can go down again, right? Usually we have this sort of pattern. Maybe that little bump there is not really what happens. The cool thing about jump is we can always go here to redo an automatic recalc, and we could maybe put this more in line, change it to 5, and it should update my graphic. And there we go right there. So that's what I call the Thanksgiving effect. Is there a pretty strong relationship that when you eat, you usually feel a lot better? And then if you keep eating, you start to feel worse. And this relationship is very what? Non-linear. Because if it was a linear relationship, what would happen? It'd be a straight line. And look what happens when we fit a line to this. This relationship, if we were to be like, correlation is causation, we'd say, oh, if you eat, you always what? Or we generally say a relationship where you eat and you feel less happy. You feel less happy. Or I was going to say less good. It sounds weird. But this is not the truth right here. There's a very strong non-linear relationship. So we have to watch out that we don't try to fit a line when a non-linear relationship is more appropriate. Frankly, what I've drawn might be best fit by a polynomial. You've got all these options that we really don't use. And even that polynomial doesn't fit so perfectly. You could always try fitting a higher order polynomial, like something like a fourth order. And you see, look at that. I can remove these. And the fourth order polynomial seems to be a pretty good fit. So if you ever do decide to mess around and jump, and feel free to ask me questions outside of class, you can do things like this and try to fit some relationship that might better explain it. So we do have exponentials, polynomials, all this good stuff. But we're going to put everything that is not aligned into the category of not lines, non-linear. So remember, there can be extremely strong relationships that are non-linear. So the strength of a relationship is how tight it is. And let's look at this. Let's do this here, because we do this on the test all the time. It tricks people. Strong, non-linear relationship. And they're showing some right here. They're showing a lot more. I want to show some with more points. If you look at these right here, all of these have about the same strength. Every one of these is about the same strength. Why? Because the bands, the horizontal spread is about the same. Does that make sense? Do you see this one right here is the weakest? This one is also kind of weak. Which is stronger? Don't look at that yet. Which is stronger here? They look about the same. Why? Because they both have about the same tightness. Does that make sense? When you look at how tight it is around it, then that's strongest. Like this is a ridiculously strong parabola because everything follows the parabolic relationship. This is still a strong nonlinear relationship. This relationship here might be the strongest. Why? It's the tightest around its form. Does that make sense? The tighter it is around the form, the stronger it is. So this one's kind of strong too. This one's kind of strong. And then things like that is ridiculously strong because everything follows the form exactly. So do not be tricked on strength, because strength is how tight something is around its form. That's why it's a different thing. Exactly. Nice job online answering those questions. John, throwing you 20 right there. Love answering those questions. This is what we would call a weak, non-existent relationship. I call it just throwing paint on the wall. There's nothing to it. This is complete randomness. If you tell me there's something going on here, I'd be like, you're reaching. It'll, like a car, oh no, now I can see it, no. So it's really hard to stretch, right? You gotta stretch, you gotta blur your eyes. This is the weakest relationship we really have. There's no good form to it. If you say it's a form of a circle, well, that's just kind of a splatter. So there's nothing really going on here. Usually we focus in on things like this, and that brings us to our last topic. Outlier, which is unusual features. And so tell me, is it weird for someone to be 190 pounds? And this doesn't mean weird or bad. Weird just means unusual. So let's use that word. Is it unusual for someone to be 190 pounds? Depending on height, because I'm 190 pounds. Depending on height, and it's nothing wrong. I didn't make this slide. Thank you, my Pearson. So if you are 6'2", 190, you're an outlier, right? Because that's an odd bivariate combination. My brother in high school was about right here. Tell me about my brother in high school. Go ahead. He was 6'3", 140. He had like a 28 or 29-inch waist. So for guys, like probably a lot of people, like 32-inch waist, 30 guys, 34, but 32. So he had like 29. He was like in the 20s. That's ridiculous, right? We ran cross country and it was like, good luck finding G's. No, that's when you get to go to the sale rack But then you don't got much of a selection. But it's not that my brother is weird or anything. He's an unusual combination. Is it weird to weigh 140 pounds? Unusual, let's say unusual. Is it unusual to weigh 140 pounds? Is it unusual to be 6'3"? Is it it is? Not too. That's bordering on unusually tall, right? It's not too unusual, but a little tall. Is it unusual to be 6'3" and be 140? Nothing wrong with that. It's just an unusual combination. So the way we gauge an outlier is that you are away from the relationship. Does that make sense? Something is an outlier in the bivariate relationship when it is far away from it. So it's not unusual to be 6'3". It's not unusual to be 140 pounds. It is unusual to be the bivariate combination of 6'3", 140. That's what's unusual. You could actually be 250 pounds and maybe be typical and not be a bivariate outlier if you were maybe, I don't know. See, it's crazy. Like when you look up Shaq or something, Shaq might not be that unusual. Why? Because he's what? I mean, he weighs like 300 pounds, but he's like 6'10", right? So we follow the relationship out. It's like, oh, Shaq is actually kind of what we would expect someone who's 6'10" to weigh. It's just that that's the way it goes when you follow the relationship. But Shaq would still be an unusual univariate. Like he's unusually high in his height. He's unusually high in his weight. But his bivariate combination is not unusual. And that's what an outlier is in the bivariate world. Yes, the bivariate relationship. So outliers do not follow the bivariate relationship. He's in the top 84% of 6'3". So, yes. So we have strength, direction, form, unusual features. Please comment on all of those for me right here. What is the strength of this relationship? Pretty strong, I'd say, right? Pretty strong. What is the form of this relationship? Linear. Ignore the outlier for the moment because that's going to be talked about in what? Unusual features. What is the direction? Positive, and the unusual feature would be the outlier. So if there was a test question, we haven't written this one like in a long time, but if it said describe this, you'd say it's a somewhat strong relationship that is positive, is a linear relationship, and has an outlier. Strength, direction, form, unusual features. So here we go, a little bit of an odd thing right here. This is actually two categorical variables because we have two machines. So rather than making one full relationship, we would take both of these right here and divide them up into their own categories and do that right there. I drew around it. So with this right here, we're putting them into two lines and kind of giving them their own process to go through, supplier A and supplier B. We don't really do that this much in this class, more of in regression, but an unusual feature here, which I don't even know how we'd write this on a test question, but it's that there's two suppliers. So it'd be better to put kind of two different scatter plots or give them their own relationships because each is stronger. If you look at what I drew around here. It's weaker. Oh, I need to mention that. A student told me this. Miranda told me this so long ago, and she became a business analytics major, one of our first actually, so long ago now. She said, Brian, if you draw around it and it looks like a circle, then it's weaker. But the tighter it gets and the more it looks like a 1, the stronger it is. Because when we talk about correlation, which we'll never do this math, correlation values range, I want to show that slide, I thought it was on here, but correlation values range between -1 and 1. And let's show Wikipedia, which sometimes is better than we even are, because I know they have the Wikipedia graphic. Wikipedia correlation. One of my favorite graphics for explaining this is right here. And so with this graphic right here, look at how when you put a 0 around this, it's correlation of 0. Does that make sense? Does that look like a 1? And what's its direction? Positive. Does this look like a 1? Wait, why are these all 1? Because the only thing that dictates strength is what it is. How tight it is, exactly. 20 points, both of you right there. And online, Sydney, 20 points. Thank you for chiming in. I love it online. So how tight it is, and all of these have the same. This is correlation that cannot be mathematically found because it looks at the variation in y with the variation in x, and y has no variation. So correlation there is just not calculable. It's just we can't calculate it. So don't worry about that. Trick question we've never put on the test, and I don't expect us to. It's just a theoretical thing. So if you notice here, as it gets weaker, if you were to put a 0 around this, it'd look like 0. But what if you were to draw around this relationship? What would you basically draw? You draw a 0. So correlation measures the what strength? Because does this have a kind of, well, linear. Linear, 20 points right there. Linear. Because is this some sort of data that has a relationship? And is it strongish? Like it has a decently strong, you can see it. It's some sort of kind of wavy pattern through it. But correlation is only for what? Linear. And if you're wondering, if you've heard other things, we're talking about Pearson correlation. There is another one, which I won't mention. But Pearson correlation is only for linear. And most of the time when people say correlation, they're talking about Pearson. I won't say the other one. It's a little bit of an interesting one. We'll teach it to you another time if you like. But this one right here, is there a relationship here? Is there some sort of strongish relationship? And why does it have zero linear correlation? Because if you draw around it, makes a zero, right? There's not a line. If you were to put a line through it, what do you think that line would look like? It'd be a what line? It's best I can, it'd be not a wiggle. Well, no, Sydney, you're right. We should put a wiggle through it, but if we force a linear line through it, the line will be no squiggle like that. 100 points online first say it. Even if you're in class and you say it, it'll all just be a what through it? Flat line, flat line. Does that make sense? It'll be a flat line through it because there's no linear correlation. Is that a question? Go ahead. Yeah. So you could, and then we would not use correlation though. So you are correct. So you could do some sort of you could do some sort of nonlinear relationship, and you are exactly right. Especially like if this was, let's say, your project or something, you wouldn't just go like, oh, I'm gonna fit a line. It doesn't work. In truth, because, and this would be a good thing too, we don't teach this, but you would fit some sort of parabolic relationship, and you would say it is explained by some sort of cosine relationship, and that comes up a lot. So you are very, very correct. I'm throwing 100 points right there. Thank you for chiming in. If this was your project and you were doing it like work for like a thesis or something, you wouldn't just toss it and be like, nothing going on. You'd be like, there is a relationship that is described by some sort of cosine waveform. Exactly right. But for now, we won't. But no, great question. So I want to go back to this slide. You will not calculate this. You will not calculate correlation. If you wanted to calculate the correlation, you would go into jump, and this is good help for your assignment. You would have your data right here, and you'd go to analyze and go to, my brain broke. Analyze, there we go, multivariate methods, multivariate. There we go. Just couldn't find it. They moved the menus. So analyze multivariate method, multivariate, double click, and we get what is called a correlation matrix. And so here we see the correlation. You can even kind of see the outliers right here. Do you see how it kind of goes away from our relationship? And we have the downward slope that we get where the line would be going through. The correlation here is negative 0.4445. But if you notice, it's not well described by a line. I could annotate off some of this, and if I delete them, let's go to redo and automatic recalc. I'm going to remove the first 3 points, and we'll actually get a ridiculously strong relationship now. So when I go here and I delete off this data for the first 3 points, it should get very strong, and look at that. Do you see now we have a crazy strong relationship? And what is the strongest negative relationship we can have? Strongest negative relationship we can have. Nice job, Luke. -1, which tells us the direction. What is stronger, -1 or +1? Same, is that right? So I can't trick you guys, I can't get you. Strength is how close it is to -1 or +1. Does that make sense? What is the weakest linear relationship? 0. And so we can see things like this should have correlation close to 0 right here, where this won't have a correlation very close to what? This will have a correlation close to 0 because it's not, and this might have a correlation of 0.2, 0.3. There's some sort of positive thing to it, but it's not very strong, and we're only measuring linear strength of correlation. So correlation is for linear. We're about to one of my other favorite topics. We'll stop at about 6:16 for our final question. We're gonna get through most of this today. So draw a non-linear association that's strong. Just draw your what again? These are test scores. Yep, there we go. Parabolic, boop, 50 points right there. Yep, that's exactly what I want to see. Just draw this, because if the points follow it, you've drawn a strong non-linear relationship. You guys remember how I made you guys say 68, 95, 99.7? One more time, you guys we're just all gonna do it as a class. I want you guys to say it online, but here's not what you're gonna say. And so if you are in another class, if you're watching this, you probably can't write this on your test, but I tell my graders to grade this way. And what I have them grade is Q, straight enough, no outliers. So one time, as loud as I said, are you ready? I'm gonna take away those 3 points from everyone. Okay, do you want the 3 points? Yeah. They're not happy in class about this. What did I just say? Louder! You got 1 point back. Q straight enough, no outliers. 2 points back. One more time. All the points back. There we go. Thank you, Sydney. Sorry, Q. Q said their roommates are getting concerned. So Q straight up, because they're probably yelling it out. Don't yell too loudly, Q. Q straight enough, no outliers. What does this mean, Brian? What does it mean? Well, think about this. Q. Both variables are quantitative. Why do we need 2 quantitative variables? Because we're making a what? Scatter plot. Bivariate quantitative. That's what that condition means. Straight enough, because the what is what? Go back to your talking about it, because careful, the one of the 4 things we talked about is what? Straight enough, because the blank should be blank. One of the 4 things, strength, direction, form, unusual features. Close. Straight enough, because we want the blank.
The form should be linear.
Bingo. We should know what these mean. Straight enough, because the form has to be linear and no outliers. I'm going to show something really cool right here that I love, because you guys know I love me some RStudio. And I know sometimes I hop into it randomly, but this is the best way I can possibly show you this. We have something here called the correlation demo, and I think this has not been reset because the font is big enough. And I'm going to show you why we say no outliers. Everyone always asks, why no outliers? Because outliers, and this is the remainder of the notes, for the most part of it, outliers can really do anything. So if we ever asked you, can an outlier make a positive correlation negative? Yes. Can an outlier make a weak correlation strong? Can an outlier make a strong correlation weak? Can an outlier make a negative correlation positive? Can it make a neither correlation positive? Because outliers can do anything. So let's run core demo here and take a look at this. So here we go. We have a super strong positive relationship. So everyone see how the correlation here, which is R, correlation is represented by R, is 1. So correlation or all outliers, all you got. Sarah right there. I'm still on Sarah 50 points. I love that right there. So does everyone see the correlation is 1 right here? Let's move this out of the way a little bit. Now let's put this right here. Oh, and the correlation is negative. I can make the correlation 0 if I want. I'll just move it down to here a little bit. Now the correlation is almost 0. It's still positive. We'll go right here. Oh, look at it. The correlation is basically 0. It was just 1 point. I could even put in a few more points over here, and it's not really helping. The correlation is still basically 0. Look how strong this is. That's a super strong positive correlation, but the correlation is actually what? Basically 0 because of a outlier. So we also said that we could have 0 correlation, which should look like a what, basically? What does 0 correlation look like? It looks like basically a what? Circle, a blob. Do you see how this has 0 correlation as I put these points in? We basically get 0. Trying to bring it back to 0 again. And what do we see? Oh, I messed it up big time. Let me put a few points in here. And I'm basically getting 0. I'm just kind of hovering around it. And where do you guys think I will put in a point now to make it cool? Let's do one more. No, I want it to be 0. Yes, 0. Finally 0. Do you see the blob? Do you see the correlation of 0? And so where am I going to put a point now? What will correlation become? 1 point. 1 outlier. Now you have to decide what is an outlier. Like I could put a point over here and it doesn't really, it's 31. I mean, it's still a bit of an outlier. So you have to watch out. Because imagine you told someone, oh, there's a super strong correlation to this. They'd be like, well, it's pretty much just being caused by the what? Outlier. So the reason we say no outliers is we don't want you explaining outliers with your correlation. Because if you have a huge outlier that is doing something, all of a sudden the positive trend we saw before, if you said to someone, imagine we had this data right here that had this really strong positive relationship, and then this appeared, and you say, oh, generally this variable has a negative correlation. You'd be like, no. And is it really that the whole thing is nonlinear? Because do you see like a big bend, like a big parabola to this? No, I mean, you could imagine it, but you'd have to kind of extrapolate in the areas you don't have data. That'll come later. But we would say here that the relationship is mainly due to the what? Outlier. So should we tell someone this correlation of negative 0.19, be like, oh, there's a correlation, a negative correlation here, a kind of weak negative correlation? No. You should probably say correlation is not a good idea for this data set. It is not well described by correlation. QQ, yes, two quantitative variables. Straight enough. Generally, we see that it follows a straight line. I know that this outlier is kind of breaking it. So I know some people are like, oh, it's not straight enough because of the outlier. You're saying it's the outlier though, right? It is the outlier that is causing the issue. There is a linear form to this relationship. Even if I were to put a whole bunch more points into here, you still see that it's still negative. It might even go to 0, but I'd say, oh, there's no real form. Oh, this is a kind of strong, or it's a super weak positive relationship. No, it's ridiculously strong except for the outlier. So outliers can do anything.
So
Go ahead, Chris. Mm-hmm.
And we're just like, if we exclude the outlier, like, is that considered a good way to answer, or would you be like?
And so we can exclude outliers. This goes back to chapter 3, I believe. We can exclude outliers generally when they're incorrectly entered, or we have a good reason to believe that someone lied or did something incorrectly. We can do the data analysis with and without the outliers, but do we ever just like toss out that outlier? No, don't toss it out. The best you can ever do is do data analysis with and without it. So if a test question were to say something like, you can toss out your outliers. No, no. Usually a lot of times they're, like I said, like if you made $50,000 one day in the stock market, we just toss that out because that's an outlier. No, you'd be like, what happened? So we don't usually toss out outliers unless we know that they're incorrectly entered or something manipulated or something wrong. It's like, imagine if we wanted to see how fast kindergartners could run, and one of their dads, Usain Bolt, was there that day and he decided to run. Could we toss that out? We can't? What did we want to analyze? Kindergartners. So can we toss out? Yes, we can. In that instance, we can. You need reasons to throw away outliers. You can't just be like, wow, that guy was fast. Maybe because we don't see how fast people are, and Usain Bolt's there that day. So if you were like, what is your population of interest? All these questions right here. But once again, with outliers, don't just toss them. Test question. Why? And I'm sorry, guys in class. I think let me do this in the room. Sorry, onliners now. Still can't see it that well, can you? Green does not. Up. Let's just make it black. I don't know if that helped. Why is this, and here I'll help the onliners. Okay, why is this not good for QQ straight enough and outliers? Not straight enough. I think this is a lie though. I prefer you just bake your cookies like right here at 100 degrees for like a minute. Because what does Brian want to eat? Raw cookie dough. You ever put it in the microwave and just heat it up a little bit? Oh, you know what I'm talking about. We're not afraid of salmonella, right? It's not a big deal. No, there hasn't. Fake news. Trying to scare us there. Do what? Hey, we have a BS in microbiology. Round of applause for that. Raw cookie dough. So I like that right. So with this in mind, we see some other plots right here that I've been making. Could you make a sketch of a weak correlation, an outlier making a weak correlation strong? What if that was on the test? What would you draw? Draw a weak correlation right now. Try that on your sheet of paper. We're about to where Brian's going to ask you a question. So try on your sheet of paper to draw a weak correlation with an outlier making it strong. So you have to know what a weak correlation looks like. It basically looks like a what? A blob. So draw your little blob, and then what do we do next? Put one way out here. Put one way away that's just going to pull the whole relationship towards it. So we've done that. How about sketch of an outlier making a strong correlation look weak? Then we draw a really strong correlation where everything's nice and tight, right? But could we draw it down? Is that, if we make that tight, is that a strong linear? Yep, it can be down. But then we put one where? Like way out that it's going to kind of make a blob in it, right? So we can think of this one right here. How about sketch of a positive, sketch of an outlier making a positive correlation look negative. Draw your positive correlation and do what? Put one right down here, right? That's going to pull it down. Does that make sense? Last but not, oh man. Do what? Correlation is not causation. I'm going to do my favorite thing right here. So we'll end class with the man who's ruining the world, and then we'll start next class with p-values also. So I got to tell you a story about a guy. We'll hear about him in a second. This guy has made many, many movies. He lives a fantastic life. He was in a really kick-ass movie, if you get what I'm saying. He was in Kick-Ass, the movie. Has anyone seen that movie? Is it good? Oh no, we had to know in it. Yes, I loved it. Oh no. We'll agree to disagree on that. We'll agree to disagree. So we see here Pearson's correlation right here, and let's continue on. And I'll mention this gentleman in a second here, and you see a lot of the same graphics we've been talking about. Do you see this graphic right here? Is that a super strong relationship? It is, but why does it have correlation 0? Nonlinear. And we have the same stuff going on right here. Once we see the science thing, we'll see it here. We'll go back to this one. But this man I've been talking about, who's responsible for a lot of deaths in the US, is Nicolas Cage.
Oh.
So Nicolas Cage right here has to be stopped because the correlation between him and people drowning in pools and being in movies is 666. And if you're not afraid now, you should be. Nicolas Cage and people drowning in pools, the more movies he's in, and that's cause and effect, right? Because correlation is not causation. But good news, you know, we've been spending a lot of money on science lately, and I don't know about that, because look at this. Wow, wait, correlation of 1 is the highest it can be, right? So the more money we spend on science, the more people are killing themselves. But that's a correlation of 1. No, you're wrong.
They're not related. They're killing themselves in a different way. Did you just compare it to all suicide?
No, this right here says that the correlation between science and suicides is almost 1. Is that a fact? Is that a fact with this data?
Yeah, even if they're correlated,
Bingo.
they're like causal.
Bingo. And you know, a lot of other things that are correlated are things like how many TVs you own and how long you live.
I think there's like a site that
We use, it's a spurious correlation.
yeah.
Spurious correlation. Also, so we'll end here in just a moment. I'll give a big bonus question at the end. Remember, there's going to be a 500-pointer. Spurious correlation, great site here. And actually, look, it's the same exact graphic. That's why we use that one right here. It was done from spurious correlation. But TV and life, how long you live. Why would people live longer if they own more TVs? Because you have more money. It's like you have more money, you buy more TVs, you have more access to healthcare. If you do it on the global scale, then it would be something like you live in a country that has access to technology and medicine and all that stuff. So there's all this stuff right here. I like it. Boom, mind blowing. John, another 20 points. Thank you, John. All his comments online. We're going to hop back here. Remember, the big thing you've learned from all this is you should always remember the phrase that correlation is not causation. Get ready for the big bonus question of the day. We'll start back here next time and finish up because we saw a correlation matrix today, but we'll talk more on it next time. The big bonus question for today is going to be a tough one. I'll try to maybe do one at the end of each class, big bonus question. So we're going to go back here to the normal applet and ask you the following question. Try to write it down. You can leave at 6:20. Someone might get it pretty quickly. Get ready. The test scores for this test are normally distributed between, and you have to raise your hand or say it online, first person online in class to get it. So, and I'll wait till I hear both answers and confirm. Test scores are normally distributed with a mean of 70 and a standard deviation of 5. I'm going to talk slowly here because automatically I would start drawing that curve out. And in the middle of the curve, I'd put what? Then 75, then 80, and then 85. Does that make sense? I'd draw my curve and start boom, 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 put my numbers underneath it. So you might have part of the curve drawn. The answer to this will be a between. When you give your answer, you must say between this and between this. You get one shot. You can't re-answer. If I do this, you get one shot. And then I'll look to see who's the first to get it online. So we'll do it in class and we'll do online. Remember, 70 is the mean. Standard deviation is 5. Remember, it's a between. You have to say between this and this amount. I feel like a hand's already going to go up. Between what percent and what, there's a little bit tougher one. Between what percent and what percent of students do we expect to make above a 72? Above a 72. I'm going to hear the in-class answer, and I'll say first. Try to get it? You have to do between. You have to say, remember, it's above a 72, between this percent, between this percent. Let's see. Do you want to go? You got about 3 seconds. Go right here. Nope. Above a 72. Oh, wait. Oh, no. Okay, go ahead. I gave an easier one. I'm going to give you 200 for that. You can chime back. Do what? So I said above a 72, right? So above a 72. Do you have your graph drawn? I said a mean of 70 and a standard deviation of 5, right? Go ahead, right here. Nope. Nope. The mean is 70, right? It's above a 72. I'm going to see who got it first online. So you can keep guessing online if you're first to get it. So just think about what your answer should be. I'll give hints. Online has not gotten it yet either. Online has not gotten it yet either.
Are you looking for like an exact? Like,
I need two numbers. More, you can be like more than this, but less than this, or between this and this percent. No, raise your hand and then say the two numbers. Go ahead.
67%.
Nope. This is a tricky question. John might have gotten the exact. Don't. Well, you got a cheat sheet down here. That has to be contained in your interval. I'll go right here and I'll go next. Go ahead. You're on the track. Go ahead. Go ahead. Nope. Closer. I'm glad we did this problem. I'm glad people are stuck because I'm glad this is one of the hardest ones on the test. That's why I picked it. I'll give it away here in a moment, but go ahead. Remember, you can only use empirical rule numbers. Maybe I should have made that clear. So I probably should have said that. Sorry. Oh, okay, wait. Reset. Only use I'm sorry. Only use empirical rule numbers. Only use empirical rule numbers. Only use empirical rule numbers. First, I saw hand right there. Above 72. Above 72. I have it shown right here. Above 72.
above 72, wouldn't it just be like between like 34 and 100?
I'll show you how to do this one. But you, go ahead. The answer, whatever you give, has to contain that. Closer. Go in the back. Close, very close. I'm throwing you 200 just for that. I'm gonna see no one's got it online. Sorry, I know we're over time right now, and I'm gonna explain how to do this one in the video. You're always free to leave if you want. Go ahead. Close, close. You guys are using the correct things now, though. Use the 50. 100 points, everyone guessing. Keep going. Nope. You guys are super close, but the 32 is wrong. Only use, I'll show this in a moment. I'm making it 1,000 points. Oh. Go ahead and back. You're right. Sorry. There you go. You chimed in a whole bunch. 500 right here. I liked it. You guys, you put it on track. Another 200 right here. Thank you guys for chiming in so much. On first person online, everyone online. I'm throwing everyone online. 200 points for all those guesses and you listening in. So great job. Let's explain how this is done. You ready? So what is above 75 according to the empirical rule? 16. What is above right here? 70. 50. Does that make sense? And what you want to do, and I'm going to do this in Microsoft Word so you can see it. It'll show up on the video now. You can leave if you want, but this is a question that's, I'm not saying like, don't leave, but this is one of the hardest ones I see for people on the test, a question like this. They just don't generally know how to do it. So this will show up on the video. Feel free to definitely pack up right now. I held you guys way over time. I should have said empirical rule from the start. I'm going to draw this online so everyone can see it. And here's what I would do if you had this on the test. First, I would draw it just like this. And then I would go into here, and I'm going to use the insert. I'm going to insert a shape, and I'm going to insert my arrow. I'm going to put an arrow here going above. And how much is above 75? What is that? That is what percent? 16%. And then I'm going to put a second arrow, and this arrow right here is going to go above what? 70. And then above 70 is what percent? 50%. Do you see how we obtain it right here? So that is just outside of -1, +1 is 32, and then cut that in half with the 16. So this area right here has to be more than this, more than that, but less than this. So it has to be more than 16, less than 50. That's tricky. And feel free to leave. Feel free to pack up. I'm going to throw you one more here to see if you guys get it. You can leave. You can really leave. Don't worry. I know I'm going over, but I want this to be in the video for people who want to see it if you want, like you watch this afterwards. What would we expect? What, according to the empirical, would be for students who make above a 62? So where would you go? Above a 62, let's draw it like we're going to draw it on our test. I would first draw it. Go ahead. You're almost right. You did the other side. The answer given was 2. I'm throwing you 500. You were so quick on it because you were right. 2.5 is right here and 16. So if you were to do the opposite of 16, you would get, or the complement, instead of 16 below here or above here, you would say 84. And John, you're so close. 84 and 97.5. Does that make sense? And then think about it. Anytime you write these two numbers, think if it makes sense. Look at your drawing. Does it look like the area is somewhere between 84 and 97.5? You're right. Last one, let's do it. Give me any random number on this curve and tell me above or below.
74.
74, below or above?
Below.
Below, let's do 74 below. You should know this one like that now, maybe. What would this be? Another 500. 300 for guessing. I like it. Online, Yuan, you got it, Yuan. You got it. And Luke also, 500 to both of you. Where would your 2 arrows go? You'd have one here. What is this below here? 50. And then what's below here? Careful. 68 is between -1 and 1. Someone raise their hand high for 100 points and tell me what's below here. Bingo, right there, 84. Does that make sense? Because above here is 1. So great job. Come up and ask those questions if you have it. Maybe I'll try a few more of these. I consider these some of the trickiest problems with the empirical rule. If you have that down, remember it is recorded, but if you have that down, you basically got how to do the kind of empirical rule stuff I might ask you to do. Hey, what's up?
Can you look over the
Look
format?
good.
The format of this?
Yeah, camera?
Yeah, just make sure it's
Yeah.
looks good.
And maybe, do you still have the graphic up for the second one? Or do this. Scroll down, because this is a quite fine way of showing this one. And you have the variables here, but you're missing a data table. Scroll back up to the other one. You were missing a data table. So do you still have all this open?
I have it in the, I do.
Good, good. Because all you'll have to do is add in a data table. You'll be good.
A data table?
Yep. And so the data table is just the numbers below it. So go ahead and click inside of the graphic real quick. And click inside of here. And click over, click the plus. Yep. And then go to data table. Yep. And what we'll do, because sometimes this one can get all scrunched, is go up here to the, go up to the table of this one. So go up to the table.
Where?
You want to scroll up the page, go scroll up on the page, click inside of here. And then go to either analyze or design. Go over to one of those. Go to analyze. Go to field list. That button right there. Because it got so scrunched, we're just going to take these two and flip them. So you're going to take family income and put it
In rows?
Yeah.
Let's do rows.
And this will make it less scrunchy.
Okay, so you want the data table?
Yep, yep.
And, all
And then what you can also do, one last thing will make it look perfect.
Okay.
And everything you have looks great there. I'll put average on that maybe, and you'll be excellent. So I'll let you input average in the title.
I already averaged this. It was like 20 million or something like that.
But then for the reader,
Okay.
yeah.
So
And
like,
then scroll back up, and I'll show you one last change to these. And this will be our example of a perfect one. Scroll back this way. Click right here. Turn back on. There we go. Click this number.
this number.
Hold Shift. Click that number down there, that very bottom number. Go all the way down there.
So,
Perfect. Go to Home. And go to General. General right here. And go to Currency. Yeah. And that helped with the decimals. Yeah. And so this chart, this one right here, just make sure to include average. You've got a perfect flip chart, or at least, and then it looks like your explanations were really good. And so this is what you want. It looks like the other ones were missing data tables too. Just insert the data tables. Just make sure you could probably put AVG before it. I know this title's getting kind of long, but maybe just put AVG there,
Okay.
and then AVG there for average, and you should have all the points.
How do I do the average? I forgot how to do it last time.
You have it right here already. It's already average, but just including it in the title, like the axis titles and stuff.
Okay.
But no, so you got it.
Okay, cool. Thank you
Yeah,
very much.
great job.
Thanks.
Hey.
I can do the Wednesday morning.
Yes. Okay. Send it on the email just so I remember, and we'll put it through. Hey, all.
Look at this for
Put
me
it
and
right
see
here.
if it's okay. I did all three of them yesterday, and I'm pretty proud. But
All right. Yeah. So
I don't
great.
know.
Yeah. I see average. I see the data types. I see X cells. Scroll down, and it looks like you mentioned the numbers.
I did. I tried to be really specific,
Mhm.
but and then there's the second one.
Great job.
Okay, I wrote like way too much for this.
Oh no. No. The grades will usually be like, hey, this is good. This is what we
Okay,
want.
good.
I think I got that. And then like this is the one I made. So I used like music preference with like how much you'd be willing to pay for a concert based on your gender.
Oh, like what you listen to.
Yeah, I thought it was kind of interesting that the streaming people are just willing to pay more overall.
Because they're probably like obsessed with like.
Yeah, because like they want the newest stuff all the time. And I thought it was kind of interesting that people that like the more traditional like media would not pay as much money. So I just thought that was
it's like streamers are like the modern people. Like I will just buy it all.
Yeah.
So if you were to advertise, imagine someone's like, we can reach the same amount of people for the same price by putting things in CDs or advertising on a streaming platform. What would you advertise on?
I feel like I would advertise on the streaming platform just because they're going to pay.
Yeah, and that's one reason. And we'd maybe look at like certain genres or things, but no, that's a big reason right there. Like that's how we leverage that information. Say, oh, these people who are listening to streaming are willing to pay more to go to concerts. So maybe if we had a high price concert, we'd be like, oh, we should definitely advertise it on streaming services, like in between, like next week in Knoxville. So
thank you.
Great job, Aaron. Let's see. Nice job online. Oh, they're all gone. Well, I'm going to end the meeting. Thank you, everyone online.